So as Unit 5e notes, you're going to be able to identify the characteristics of a radical function. We did some of this in Unit 1. This is a lot of review. First, we're going to have a function here. You're going to look at it, see that it's a cube root function. And first, we're going to start off with domain. Domain is your x values. With domain is the x values. And if you're looking at the x-axis, x values are the horizontal here, left, how far left to how far right will the graph go. So when I'm looking at the graph, I'm looking at the farthest most left arrow. Are there any breaks in the graph? Nope, it's continuous. And how far right will it go? It'll go forever. So one thing I've done in the past is I take the whole graph and I squish it all the way to the x-axis. So bringing this arrow up, and I'm just going to make it as a horizontal line here on the x-axis. I'm going to try to draw it as straight as I possibly can. So this graph, if I can squish the whole graph, slide it all up and squish it to the x-axis, make it a straight line, there's no breaks in it at all. And it goes from negative infinity to positive infinity. So that's going to be our domain. And I apologize for how I'm drawing these here, but it's negative infinity to infinity. The range is going to be the y values. So I'm looking at the y-axis. If I take this graph and I squish it to the y-axis, so I slide this arrow over, this is going up a little bit, so it's going to go, when I slide it over here, you go vertical and squish it all the way to this arrow here would slide over, and it's going down a little bit. So then I could read just the y-axis, and it goes from, and always the smallest numbers to biggest numbers, so negative infinity to positive infinity. So and the endpoint, turning point. This is where in the graph is the slope really changing dramatically, and this is this point right here. And that point is at 1, negative 3. Erase that. 1, negative 3. Keep going. End behavior. So we have as x goes to negative infinity, so that's x is going left. What's happened to the y values? Well, this is also going down. The y values is going down to negative infinity. The other side, we have as x goes to positive infinity, so that's going to the right. So we're looking at the right side of the graph. What's happened to that arrow? It's going up slowly to infinity. So that's end behavior, ends of the graph. Increasing interval. So let's look at our graph here. We have, as this graph is going from left to right, it is continually going up. Up, 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 up. It never stops going up. So the increasing interval is everything. So it's negative infinity to infinity. So every part of the graph is going up. And not applicable or none for decreasing interval. Alright, next one. Find the characteristics of the given radical. So here we have, this is a square root function, so we have a starting point, and the endpoint or starting point here is at 0, 4, so we might as well write that right away. 0, 4. The domain. Domain is how far left to how far right. Well, if we continue with this slide and everything, squishing it down to the x-axis, this endpoint will come down to 0, 0. And we slide this whole graph down to the x-axis, and so the domain starts at 0, and there's an actual point at 0. So when there actually is a closed point, filled in point, that's equal to, and so we draw a bracket, 0, and then it goes to the right. It's continuous to the right forever to infinity. So it goes to infinity. and it's not included. Infinity is not a number, it's just kind of a thought theory. And so it goes on, and so it's not included. Range. Range is going to be your y values. Well, here we go. This is the lowest y value, and then as this goes, it's going to continually go up. So this graph, if you slid it over or squished it over to the y-axis, sorry for that, a little off, goes up. This will continually go up, up, up forever. So it starts at 4, and it'll go up to infinity. Again, at 4, there's a closed point. Closed point means it's included or equal to, and goes to infinity. End behavior. As x goes to, now there's two ends of the graph. We have this farthest leftmost point, which is the endpoint, and then the farthest right. I'll circle that a little bit. So we'll start here. As x goes to, well, this x can only go to 0. That point is 0, 4. Can't go any further left than that. So we'll say as x goes to 0, what's happening to the y? Where is that going? Well, that's going to just go to 4. That's as far as it can go. To the right here, the right side of the graph, we have as x goes to, and that'll continue to go to the right forever, to infinity. And what's happening as it goes to the right forever? Well, it'll continually go up forever too. So it'll go to positive infinity. Increasing interval. Let's look at this graph here. Increasing interval. As the graph goes along, goes along, it's continually going up again. So very much like our last one, it's going to increase from, oh, hold on, not going to be from negative infinity. It's going to increase from 0, this is the x values, 0, and it's going to increase forever to infinity. So it can't increase from negative infinity because the x values don't go to negative infinity. And decreasing, it doesn't decrease, so not applicable again, or none you can write. Yeah, those are notes on characteristics of radical functions.